Hey everybody, we are going to continue with 7.6 dilations today. I have a few problems that I want to go through. I know yesterday we didn't get through all of those problems because of that pesky bell at the end of the day. That bell needs to change to like 4:30, 5 o'clock. That'd be perfect. So we could have math for like 2 hours. How sweet would that be? That would be so awesome to have math and geometry for 2 hours. Awesome. Unfortunately, we're still cut down to 45 minutes. Boo. All right, anyways, we're going to talk about 7.6 today. Our lesson today is going to be a little bit shorter because we did talk about it yesterday. But let's get started. Let's get this party started. We're going to be identifying and drawing dilations today. Not so much drawing. We're just going to be identifying proportions and dilations and scale factors. And these two wonderful words, enlargement and reductions today. So the very first thing I want you to do is I want you to write this down. We talked yesterday, you had written down the definition of a dilation. You had a little drawing, and that drawing and that definition looked complex. Okay, we started talking about enlargements and reductions. I didn't have you write it down, but I want you to write it down today. It says a dilation with a scale factor of greater than 1. So if it's bigger than 1, it is an enlargement. Okay, it's also, you could also call it an expansion, but we call it an enlargement. A dilation with a scale factor of less than 1, the exact opposite, is a reduction. It gets smaller, where an enlargement gets bigger. Normally, if a voice goes deeper, it means it gets bigger. And if it goes smaller, it gets higher. Okay, so we're going to be talking about enlargements and reductions. Just look at your scale factors. And in fact, you could just look at the shape itself, okay, but to see if it gets bigger or smaller. But make sure that you are focusing on the image and the pre-image. Which one is your pre-image? Which one is your image? That's the important piece. All right, so let's try one. All right, so as you're looking at this figure, it says, tell whether the dilation is a reduction or an enlargement, then find its scale factor. Okay, very first thing, look at the pre-image and look at your image. Which one is your pre-image? Which one is your image? Well, because this square has all of your, or this rectangle has the primes, that's what tells you what is your image and gives you your pre-image along with it. So if that blue square, you will notice that is your pre-image. Your red square, that is your image. Rectangle. It's not a square. It is a rectangle. Okay, so when you look at that, when it goes from your from your pre-image to your image and it gets larger, is that a reduction or an enlargement? That would be an enlargement. Absolutely. Okay, now we have to figure out the scale factor. Yesterday we talked about the center of dilation, basically where you look to start. And our center of dilation, you will notice, is Q. Okay, when you're putting into a scale factor, yesterday we also talked about, we used from our center of dilation and we look at how far the distance is between that and our image. Okay, so if I look at starting at my point of dilation and I go to my image, you'll notice it goes from Q to U prime. Okay, and then we look at that, we look at our center of dilation over to our pre-image. So our Q to U prime, that's going to be always our top number. Okay, and our center of dilation to our point, or our pre-image, that is going to be your bottom or your denominator. So when you look at your scale factor, it's going to become a ratio. All right, so we know the distance of Q to U prime is going to be 24, and from Q to U is going to be 9. So my scale factor here is 24 over 9. However, we can reduce this down. What can we reduce this down by? 3. Divide each one by 3, and we get 8 over 3. Okay, so this is an enlargement with a scale factor of 8/3. Okay, 8/3. All right, to go from my pre-image to my image, it has an enlargement of 8/3. Okay, so again, use your, from the center of dilation to your image, that is going to be your numerator, and from your center of dilation to your pre-image, that is going to be your denominator. Okay, alrighty then. All right, write this next one down, and what I want you to do is just kind of follow along as to what I am going to do. Okay, so pause now so you can write it down. All right, so when you look at this shape, we know a dilation is a transformation. Because it's a transformation, we know that they are similar. The objects are going to be similar. It's the same shape, just either bigger, smaller, or slit, or moved, in other words. So we know that they are going to be similar. When we know that they are similar, that makes them proportional. Okay, so when we look at x here, we are finding x, which you will see is going to be the distance from P to Z, right here. All right. When you are finding x, you have to set up a proportion. Okay. So as I set up my proportion, again, the ratios on both sides have to be the exact same. So when I set up this proportion, I'm going to look at my rectangles first, and I'm going to write my pre-image side over my image side. Now you could go the other way. You could go 15/9, but you need to make sure that the proportion, or sorry, that the ratios that you set equal to each other are in fact equal to each other, that it forms a proportion. Okay, so on top I put my pre-image, I'm just going to call it PI, over my image, and I'm just going to call that my IM. Okay, so my pre-image side over my image side. Now, if I look at this, I notice I have x here as the distance from my center of dilation to my image. Sorry, to my pre-image. Okay, so PZ is from my center of dilation to my pre-image. Because pre-image is on top in this fraction right here, I'm going to do the exact same for my distance to my pre-image on top there. Then my distance to my image, which is 35, is going to be on my denominator. Notice I used the exact same ratio. I went from my pre-image on top to my image on bottom. On the other side, pre-image over my image. Okay, from here, we know how to solve a proportion where you cross multiply. You get on 9 times 35 is 315. And you get 15x on the other side. Divide by 15 on both sides. And your answer is going to come out as x equals 21. Okay, so my x is 21, all because I was able to know that this is going to be a dilation. Now, that dilation tells me what it is. Now, if I look at this shape, okay, I'm going from my image, or sorry, my pre-image to my image. And when I do that, I want to know if that's a reduction or an enlargement. So if you look at my pre-image and I go to my image, is that going to be a reduction or an enlargement? It is going to be an enlargement. Okay, an enlargement. When you look at this, the blue shape is my pre-image, where the red shape is my image, and when it goes bigger, when it gets bigger, okay, it's going to be an enlargement. Sweet! Moving on. Okay, here's the only thing that I really want you to write down, and it kind of gives you a definition of how to do this, how to find a dilation on a coordinate plane. So write this down, and we'll try one problem. We have one more problem after this. All right? Write it down. Okay, basically, when you look at this shape, all you're going to do is to get from P to P prime. Okay, you know there's a dilation that's happening. You know you have your scale factor here. You already find your scale factor, or it was already given. Okay, so what you do is you take that scale factor and you multiply it times your x and your y. You multiply that scale factor times your x, then you multiply that scale factor times your y, and you come up with your P prime. Okay, or you come up with your new image point. All right, so take your pre-image coordinates, multiply it by your scale factor, and you get your image coordinates. All right, so what I want you to do is try the next one. Give this one a shot. Okay, I want you to write this down. Draw the image of the triangle with the vertices. You don't have to draw that. Okay, so you don't have to draw it. All I want you to do is give me the new coordinates. Okay, so give me what r prime is. Give me what s prime is. T prime and u prime. Not Optimus Prime. Oh man, I just love those jokes. All right, so r prime, s prime, t prime, and u prime. Give it a shot. All right, so now we know our scale factor on this is going to be a negative half. When we have a scale factor of negative half and we have our original points, all you do is you take those original points and you multiply it by your scale factor. So r, okay, again, we're going to multiply r by a negative half, both the x and the y coordinates. So if I multiply 0 times a negative half, I get 0. And if I do it again, I get 0 again. So r prime doesn't really move. All right? Now, if you look at s prime, again, you do the exact same thing as we did for r prime. You take that negative half, that scale factor, and multiply it by your coordinates. So 4 times a negative half is a negative 2, and we already know 0 times a negative half is 0. Moving on to the next point, and you just keep multiplying. Okay, you now have negative 1, 1. And last but not least, you would end up with 1, 1. So if you look at this shape, now my question to you would be, we are done. Those are the points. But one last question. What do you think this would be? An enlargement, or would this be a reduction? And be able to tell me why. Okay, you told me what it was. Now tell me why. Good. Okay, I'm glad. I hope you got it right. Okay, when you look at this, this is going to be a reduction. Okay, remember when we talked about reductions and enlargements? Enlargements are greater than 1. Reductions are less than 1. So when we have a scale factor of negative half, well, negative half is less than 1. So because of that, it is going to be a reduction. All right, that's all I have for you today. Is just that piece of dilations. All right, so what I want you to do is get the homework from me now in class, okay, and start on the homework. All right, reductions, enlargements, scale factors, dilations. Love it.